Hey guys, Calvin here. I want to make a short video about physics and chemistry. So, what I noticed was that when a gas, right, was burning on the pot, right, the fire from the bottom feels much more hotter than the top here, right? And that just came to realization, right? The fire is increasing, radiating out from the fire and warmth and hotness into the pan, right? And that makes the molecules move faster and faster and faster, random at random entropies, right? So meaning low entropy was just cold and high entropy was just hot. High entropy was just entropy is just a matter of molecules moving at random speeds. So like hotness contributes to the hotness, and that makes the molecules move faster and at random speeds. So random directions, right? Random directions. And as the fire heats up more and more, right, the molecules move faster and faster, right? And that means higher entropy, right? And then if I put my hand here, for example, right, while the gas was burning, of course I'm not actually gonna cook something because like it's already cooked right here, cooked rice, you know. And I put my hand here, right? It's gonna feel warm because of entropy. I'm gonna place my hand right here, right? And if it's becoming hot and it burns, right? That's because your skin, right, is contributing to high entropy. It's the pot to the hand, right? It's making your hand become high entropy. Even though it's like homeostasis and stuff like that. I'm gonna get into that a little bit later in a later video. So basically, that's all I have to say. And about that, the the thing, right? The thing between heat exchange and the distillation, right? There's many materials that can absorb heat better than others. And like this rock, for example, right? Can you explain why this isn't very hot compared to this part down here, right? It's because as the molecules move faster and faster, right? And then faster and faster, right? This will feel a little bit warm, by the way. So yeah, it feels sometimes hot, sometimes warm, you know. And because this is such a small opening, right? Small opening. I might be wrong here, but this is such small opening that molecules moving faster and faster. Sometimes come pass through here and pass through here and pass through here, and then like they can't come past like down here. So like the molecules in here would be moving randomly until they disperse and finally become cool again. So like yeah, so like according to the second law of thermodynamics, you can't have a heat must flow from hot to cool, right? And you can't have something heating up without any input. So like this fire here, right? That's the input and just the output. So then I want to say, why is summer hot and why is winter cold? Hold on, let me get my notebook. Alright, so if you can see here, right? Let's say this was summer here, right? And it's the ground here, right? This the ground, right? And that's the, let's see here. That's the pole, right? That's the water. This was the water. And this is land, right? Because the land has a lower heat absorption. Lower heat absorption, right? And this one has a higher heat absorption. This one will heat slower compared to the land, right? This water will heat slower compared to the land because it has a higher heat absorption, and this one has a lower heat absorption. And let's see here, right? So, what happens at night then? What happens at night? Well, the water, knowing that it has a higher heat absorption, will radiate heat back into the space, right? Because we can't hold any heat. Otherwise, that would violate the second law of thermodynamics. Hot to cool, right? So, the land, right, known as the lower heat absorption, will give out first. So, and then the water will give out second, because the land has a lower heat absorption and will, since it absorbs heat the fastest, it must also release heat the fastest. And water, knowing that it absorbs heat the slowest, must also release heat the slowest. That's why you see people saying that they use water as a medium. So, knowing this, right, I ask you a question. Let's say this is the Earth, right? Where's the, let's see, right? Where's the bucket? There's no bucket here. There's no bucket here, I guess. Let's say this is the Earth, right? Let's say this is Earth. Let's say this is what you call it. This is sun, right? It's radiating the energy, right, in photons. And the sun, being the sun that it is, of course it warms the Earth, right? It's releasing concentrated energy photons, and the Earth releases it back as higher entropy photons, right? So sun releases low entropy photons. The sun releases high entropy photons, and the Earth releases low entropy photons, right? Releases back as heat. This one's more concentrated. This one's more spread out and stuff like that, right? Because the Earth, if the Earth just kept like having the sun give it concentrated energy, right? The Earth would warm up considerably, and that would accelerate global warming even further. And so, I ask you this question. If the sun gives Earth the energy it needs, right? What's the point of the sun giving the Earth's energy? Like, for example, let me rephrase my question a little bit. Let me think about it. If the sun is giving the Earth energy, right, and the Earth is radiating it back just as much as the sun gives it, right, what's the point of the sun giving it energy? Okay, so since this will be a short video, I'm just gonna be heading out and celebrating Mother's Day. Happy Mother's Day, all.